Hello students. So it's just a few days that we have completed the Indian Economic Service IES examination. So today we have come up with the paper solution for IES 2024. So let us see that what is the question they have given. We know obviously I have already discussed a section where I have told what are the pattern or what are the papers are there included in an IES examination. For IES you have General Studies, General English, which is common to both for IES and ISS, and in addition to that, for this what you have is the economics paper, which are four: paper 1, paper 2 and paper 3, Indian economy, and it has been divided like one section this, second section like this, it is included. So let's see what is the first question which they have given for you, and that is, if the demand function P is 4 minus 0.5 q square, for what value of q will the price elasticity of demand be unity? So it will be what? Okay, so demand function, let me tell you, demand function is given by what? P equals to 4 minus 0.5 q square, right? So first we have to determine the demand function. How we will do? We will use the chain rule. Okay, chain rule, we know u equals to 4 minus 0.5 q. Okay, so P equals to u square, right? So what we will do? Del P by del Q, that means del U square by del U into del U by del Q, that will come to minus 4 plus 0.5 Q. Okay, so now what is price elasticity of demand? Price elasticity of demand is del P by del Q into Q by P, right? So the answer will come what? Q with respect to P, so 0.5. So we have to substitute del P by del Q and P into the elasticity formula. So that will be what? ED equals to minus 4 minus, this is the derivative which you have got, right? Now this multiplied by Q by 4 minus 0.5 Q square, because we know the formula is what? The formula is dP by dQ into Q by P, this one. So we have to set the elasticity of 1, because we know it is 1 elasticity. So the equation will look like this: minus Q by 4 minus 0.5 Q equals to 1. And from the first equation, if I solve it, it will come Q equal to 2.67, and from second equation Q minus 8. So now we cannot take negative quantity, so the answer for U will come Q equals to 2.67. Okay, so this is the first question. Now coming to the second question, if a production function is homogeneous of degree 1 following constant returns to scale, we have to show that the marginal productivity and average productivity functions are independent of the absolute amount of the inputs but depend on the input ratio. Okay, so first we know homogeneous production function given by what? FKL, that is lambda FKL. So the marginal productivity, how we will find out? Del F of KL by del K. This is marginal productivity for K. Similarly for L, we will divide by del L. Now average productivity, how we found? Average productivity for K, how we will found? F of KL by L, because it is divided by. Okay, now homogeneous property and input ratio we have to do. How we will do that? Yes, I will explain you the full thing. We know the homogeneous property is what? F of R L L equals to L of F R 1. Okay, so we have to go for the marginal productivity of capital. So now we will explain the full thing. Okay, so we know that the homogeneity property, that marginal productivity capital is what? MPK is equal to del F KL by del K, right? So mpk, since r is a constant, so what it will be, 1 by r, then the whole thing, right? So now f r l comma l will be what, lf r comma 1. So if we differentiate, then it will come f r comma 1 plus l del f r comma 1 by del l. Okay, so mpk will be what, 1 by r f r comma 1 plus l del f r comma 1 by del l. This is the whole thing which is coming, right? So we know the marginal productivity of labor, and using the homogeneous productivity, f r l comma l is equal to l of this one. I already told you, we know average productivity of labor. From this, what the conclusion you can draw is that mpk, mpl, apk, apl, what they are proportional to, mpk depends fr1, mpl depends fr1, and its derivative apk fr1 by r, and this one fr1. So this is your answer for the second one. Now we will move to the third question. Okay, the third question, what is there? So the third question, what is the peak load pricing with reference to power sector, and in what way will it increase economic efficiency? So what is peak load pricing? Yeah, it is the charging. Peak load pricing means very easy. It is a pricing strategy where prices are higher during periods of high demand and lower during periods of low demand. This approach is particularly relevant in the power sector. Why? Because the cost of supplying electricity can vary significantly depending on the time of day, where the cost of supplying can vary. Now what is the application here? In what way will it increase economic efficiency? Finally we have to tell. We have explained. In the power sector, electricity demand fluctuates throughout the day. Why? Because typically peaking in the morning and evening when residential usage is high, and dipping during the night and midday. So power plants and utility face higher costs during these peak periods because they may need to bring additional, often less efficient and more expensive. So to manage this, like higher prices during peak period and lower prices during off peak period. So what are the benefits and increased economic efficiency from this side? Demand response and load shifting. Peak load pricing encourages consumer to shift their usage to off-peak times, reduce need for capacity expansion, optimal resource utilization. We can see environmental benefits are there, reduce reliance on less efficient peaker plants. Economic signals, like consumer receive accurate price signals, what is the real cost, and fairness and equity. Okay, like peak hour 6 p.m. to 9 p.m, off peak hour 12 a.m. to 6 a.m, mid peak hour 9 a.m. to 6 p.m. you can take. So if we can take the example, peak load pricing in the power sector, it's one of the vital tool for enhancing economic efficiency, and by aligning prices with the actual cost of supply, it will incentivize consumer to adjust their usage pattern. Now macro, what is the difference between Ricardo and Kalecki theory of distribution? We have to say the difference. So what is Ricardo? Classical economics. Ricardo's theory rooted in classical economics and focus on the distribution of income between landlord, capitalist and worker. Labor theory of value, rent, all these things are their wages. And Kalecki, Marxian and Keynesian, totally different. The degree of monopoly, markup, pricing, totally different. Okay, so if we tell the comparison, Ricardo classical economist, Kalecki Marxian, value and price, obviously labor theory of value, here markup, pricing, monopoly. Ricardo distribution determined by the productivity, role of effective demand and class struggle, right, implicit in the competition. So Ricardo's theory of distribution is grounded in classical economics, obviously, and on the other hand, Kalecki's theory integrates Marxian and Keynesian ideas. Okay, now coming to the eighth question, define Hicks-Kaldor compensation principle. What are the main criticisms against this compensation principle? So what is that? Hicks-Kaldor compensation. What is that? So the Hicks-Kaldor compensation principle is a criteria used in welfare economics to evaluate whether an economic change or policy improves overall social welfare. Okay, this principle is rooted in the ideal of potential Pareto improvement. Like the principle asserts that an economic change or policy can be considered an improvement. According to Kaldor's criteria, those who benefit from the change could potentially compensate. And according to Hicks' criteria, those who are harmed by the change, means a loser, could not potentially bribe the winners to forego the change. So what are the main criticisms? If we write it down, what are the main criticisms for your Hicks-Kaldor ETH question? So the ETH question, we can do the comparison on the basis of lack of actual compensation. First, measurement. Third, distributional concern. Okay. Fourth, dynamic effects. Ethical and moral more are there. Ethics wise, Pareto criteria, right? So while the Hicks-Kaldor compensation principle, it provides a useful framework evaluating potential improvement in economic efficiency, it has significant limitations, right? Now second last question for today. Show that the production function Q equals to log of L beta 1 K beta 2 is concave for all the beta 1 beta 2 greater than 0. How will show that? To show that, okay, first we have to write the function Q equals to log of L beta 1 K beta 2. Okay, now we can rewrite this way. Q equals to beta 1 log of L plus beta 2 log of K. Okay, so now first order derivative, how we will bring the first order derivative? Del Q by del L, that is with respect to beta 1 by L, that is equal to beta 1 by L, and del Q by del K, that is beta 2 1 by K, that is beta 2 by K. Okay, now the second order derivative, how we will get that? The second order derivative, del square Q by del L square, so minus beta 1 by L square minus beta 1 by L square. Okay, and del square Q by del Q square, that comes to minus beta 2 1 by K square equals to minus beta 2 by K square. Okay, so del square Q by del L del K is equals to 0. Now we have to construct the Hessian matrix because it is very important. How we will do that? Just see, the Hessian matrix is being produced like del square Q by del L square, del square Q by del K del L. Okay, and here del square Q by del L del Q, del square Q by del K square. Okay, and we will find that we have to check the negative semi definiteness, and we will get lambda 1 is equals to minus beta 1 by L square, lambda 2 is equals to minus beta 2 by K square. Okay, now the eigenvalues of the Hessian matrix, what are they? Are negative. So the Hessian matrix is negative, semi definite, so the function is concave for all beta 1 and beta 2. Okay, now the last question for today, specify an orthogonal factor model by mentioning the underlying assumption of the model. So what is an orthogonal factor model? It is a statistical model which is being used in factor analysis to describe the variance and covariance structure of a set of observed variables in terms of a smaller number of unobserved variables, which are called factors. So we know linearity, what it is, that it is in linear. We have studied also like xy, how it is linear, like this one, f1 f2, you can see any square? No, so that means it's linear and it continues. Okay, common factor means a common factor fj, these are uncorrelated. Then unique factor, these are all unique, right? For covariance, ei and EJ, it is 0 for I not equal to j. Similarly for FJ and EJ, 0 mean and unit variance, and there are unit factor variance. Okay, so this given this assumptions, the covariance matrix of the observed variable, it can be expressed as this plus this. Okay, and this is what? Matrix of factor loading. This is the matrix of factored loadings, and this is the diagonal matrix of unique variance. Okay, so this assumption provides a framework for the understanding the structure of correlations among observed variables through a smaller number of underlying common factor, and the orthogonality of the common factors simplifies the interpretation and estimation of the model. So till this for today, the IES 2024 paper has been explained. Tell me if you face any problem for each of the questions. Thank you so much for watching the video.